In today's video, we are going to be looking at 2020 further mathematics solutions, specifically for questions 4. And question 4 says that find the Cartesian equation of the curve with polar equation r equals to cos squared theta, and hence show that the equation of the tangent to the curve at the point a half and pi on 4 is r equal to 1 divided by root 2 bracket upon 3 sin theta minus cos theta bracket close. So the last part, the second part, is actually a proof. So now, to show this, before going into the equation, let me give you a summary of what polar coordinates are all about. So when we talk of polar coordinates, we know coordinates xy, right? In the Cartesian equation, or in the Cartesian coordinate, a point is represented as xy. But now when we're talking of polar coordinates, a point is represented as r theta. Now, what is this relationship of r theta? Now let's look at an example. Let me draw a Cartesian coordinate, our normal Cartesian coordinate. We know that normally this is our x-axis and this is our y-axis. Now if we take a line, let's name it a line which is a radius, and we take with respect to this angle, let's say theta, then there is something very special about this. So this is actually a right angle triangle, because this angle here is 90. Now normally we name this r, which is the radius, because if we look at it in a bigger picture, this is actually a circle of radius. This is actually a big circle, but just a portion of it is considered. It's actually a big circle, but just a portion of it is considered to study the relationship between the coordinates. Now looking at this, we see that this coordinate here is our y coordinate and this coordinate here is our x coordinate. It's clear. Now we know that from here, sin theta is simply the opposite, which is y all over the hypotenuse r, and cos theta here is simply the adjacent coordinate x all over the hypotenuse r. So here, this one implies here that our y will be r sin theta. This part is clear. And here it implies that our x is r cos theta. So basically, this is what we're going to be using throughout our solving. This is what we're going to be using. So you need to be familiar with this. These are the two main formulas. I can say formulas. Now looking at this from here, from our Pythagoras theorem, we see that r squared, right, since it's a right angle triangle, is x squared plus y squared. This part is very clear. Now if we try to replace our values of x and y, we discover that r here will simply be r squared. So if we replace our value, we see that here will be r squared to be equals to, what is our x? Our x is r squared cos squared theta. Now plus our y there is r sin theta, so it will be r squared sin squared theta. We discover that r is common throughout, so we have 1 to be equals to cos squared theta plus sin squared theta plus sin squared theta. Actually, this is the basic formula in the trigonometry. We are all aware of this formula. So this is just to testify that what we are doing is actually correct, because it is in agreement with trigonometry. And here we are dealing with angles now and the radius. So now going back to our question. What do we know? The question says that we should write the polar in Cartesian equation, the polar equation r cos squared r equals to cos squared theta, cos squared theta. So what do we know? What is our r? Our r is simply x squared plus y squared, the square root because we saw that r squared here was x squared plus y squared. So our r will simply be the square root of x squared plus y squared. So we have that. Now this is our r. This will be equal to, now our cos theta here is x all over r. Now since we are dealing with cos squared, so we are simply going to square this. So we are going to have from the square root of x squared plus y squared equal to, this will be x squared divided by r squared. So if we can recognize r squared is x squared plus y squared, so finally we are going to have the square root of x squared plus y squared. Now in this case it will be equal to x squared all over x squared plus y squared. So we can linearize our formula by simply multiplying all through by x squared y squared. So if we look at it very well, we see that this will actually be, x squared will actually be equals to x squared plus y squared, now times this, let me say to the power 1, the one on the denominator on the right hand side, multiplied by the square root of x squared, rather I'll write it like this, x squared plus y squared, all that to the power a half. So since x squared plus y squared and x squared plus y squared here for the first and second terms are the same, then we are simply going to have our final answer to be x squared to be equal to x squared plus y squared to the power 3 on 2. Now 3 on 2, why? Because from our basic law of indices and logarithm, multiplying two indices of the same base, we simply add the powers. Here the power here is 1 and here is a half, so adding that we'll have 1.5, and 1.5 is equivalent to 3 on 2. So this is the solution for the first part of the equation. Now looking at the second part of the equation, which says that hence show that the equation of the tangent to the curve at the point a half pi on 4. So we are talking of a half. Our point here, this part B of this solution, our point here is a half, and pi on 4. We should first of all have it in mind that pi on 4 is 45, right? And actually this is equivalent to r theta in Cartesian coordinates. Now we know that our equation of the equation of tangent, the general equation of a tangent is given by y minus y1 equals to mt, which is the gradient of the tangent, into x minus x1. Now looking at it very well, our y1 and x1 are the values, the initial conditions that are given to us, which are these conditions here. This is here we have to express it in polar coordinate. We have to express y1 and x1 in polar coordinates, then we come and substitute it back there. So in effect, what do we need to do? So we are going to actually put so we are going to have now our y minus, we saw that y1 was r sine theta, y1 was r sine theta, but in this case we're talking of 1, right? To be equals to mt into x minus x1 was r cos theta, but in this case we're talking of 1, the initial conditions. Now we are going to look for m of tangent. M of tangent here is simply the gradient or the first derivative of that function, of the function that we got above. Now look at it. We have been given our Cartesian equation here, r equals to our polar equation here, r equals to square theta, and we have converted it to the Cartesian equation. We have converted it to the Cartesian equation of x squared equals to x squared plus y squared to the power 3 on 2. We are going to use this equation star to get our m of t. M of t is simply the first derivative, and the first derivative we know that is the tangent of a function, and the tangent of the function is simply given as the difference between the y coordinate divided by the x coordinate. Now in calculus we look for the derivative, in coordinate geometry we look for the gradient, while in trigonometry we look for the tangent. Now here we are going to have dy on the x. So we have our function. We had the function was x squared to be equals to x squared plus y squared to the power 3 on 2. So we are going to use that to look for our m of tangent. So basically when we differentiate x squared, we are going to have 2x to be equals to, now differentiating this function, the formula or what I usually use is you bring down the power, this is very important, you bring down the power 3 all over 2, you differentiate the function inside, which will be 2x, now plus here will be 2y, but dy all over dx. Since here we are differentiating with respect to x, now we copy the same function x squared plus y squared to the power, we reduce the power by 1. We copy the function and reduce the power by 1. So that's what I usually use. What did I say? You bring down the power, you differentiate the function, you copy the same function, reduce the power by 1. It's actually a formula, a phrase that you can actually remember whenever you have derivatives of this form. So now we are going to simplify results. So simplifying, you are going to have 2x to be equals to 3 on 2 here into we can factor out. So looking at that, we can factor out 2, so we'll be left with 3 into x plus y dy all over dx in bracket. So this will actually be x squared plus y squared. Now this one is a half, and a half simply means that is the square root of that. So we are going to divide all through. So if we divide all through, we are going to have something like 2x divided by the square root of x squared plus y squared to be equal to 3 into x plus y dy on dx, dy all over dx. So we are simply going to make dy on dx subject. So to do that, we are going to have 2x all over 3 the square root of x squared plus y squared, x squared plus y squared. So this is simply going to give us x minus plus y dy on dx. So we send our x the other way. Sending x the other way, we are going to have 2x all over 3 the square root of x squared plus y squared. So this minus x, this will give us y dy on dx. So we divide all through by y. So dividing all through by y, we are going to have 2x divided by 3y the square root of x squared plus y squared. So minus x on y, now to be equals to dy on dx. So in effect, this simply means that our mt will be 2x all over 3y the square root of x squared plus y squared minus x on y, So now that is our formula. We just have to input now our values. Now to put in our values, we know that our x is r cos theta, so this will simply be 2r cos theta divided by, this will be 3r sin theta into, this will actually be r, so this will actually be r times r minus it will be r sin theta, sorry, it will be r cos theta, divided by r sin theta. So simplifying that, we're going to have our mt to be equal to, we see that r here is going to cancel with r, cos 45 and sin 45 are equivalent, right? So this is going to go away with this, so r here was a half, and a half here simply means that 1 divided by a half is 2, so it will be 4 on 3 here, minus, now we have this will be 1 minus 1 because r cos theta and r sin theta are also equivalent, so this will actually give us 1/3, so our value here should be 1/3. That's our gradient, that is the value for the gradient of the tangent. Now going back to our formula, the formula that we had here, this formula, we're going to substitute our value here, so we're going to have y, so we're going to have y minus y1, y minus our y1 in this case is r sin 45, and our r is a half, sin 45 is root 3 on 2, so it should be a half root 2 on 2, sorry, not root 3 on 2, root 2 on 2 to be equal to, now there we have 1/3 into x minus, now our x1 is r sin, our x1 is r cos theta, right? So which will be a half cos 45 is root 2 on 2, so remember cos 45 and sin 45 are equivalent, so simply here we're going to have trying to simplify, we're going to have root 2 on 4 to be equals to 1/3 into x minus root 2 on 4. So we continue with our simplification, we're going to have now y to be equal to, now I'm going to bring, it will be y minus 1/3 x, so basically I send this term to the left side, to the left hand side, to be equal to, and then I'm going to send now this term to the right hand side, so it will be root 2 on 4 now minus root 2 on 12, so doing that, we know initially that y is will be r sin theta, and this will be 1/3, x is r cos theta, so this will simply be, now the LCM of 4 and 12 is 12, and 3 here, so this will actually be 3 root 2 minus root 2 divided by 12. Now this is so because this will simply give us 2 root 2, right? This will give us 2 root 2, so basically we'll have r, we factor out r, we are going to have sin theta minus 1/3 cos theta to be equal to 2 root 2 on 12, which can further be simplified to root 2 on 6. Now we are going to divide all through. We can first of all multiply here by 3, so multiplying by 3, we are going to get r into 3 sin theta minus cos theta to give us multiplying by 3 here. We're going to have root 2 on 2. Basically we're going to have root 2 on 2. So because 3 will go to 6 2 times, so dividing all through now by that, we're going to have r now to give us root 2 all over 2 in bracket 3 sine theta minus cos theta. Now let's look at it to see if it looks like what our proof says. So basically we have 1 above there. So what we need to do here is we multiply top and bottom by root 2. So if we multiply here by root 2 and multiply here by root 2, we're going to have r to be equal to, remember I haven't changed anything here, so r root 2 times root 2 is going to give us 2. Now divided by 2 root 2 will give us 2 root 2, and we know that this would not change, sine theta minus cos theta, and now our 2 is going to cancel, will be left now these two, the 2 will go away, so we'll be left with r equal to 1 divided by root 2 into 3 sine theta minus cos theta. So the proof is finally out as required, so you can just write here as required. So as required. So thank you guys for watching till the end, and if you made it this far, it means my content was helpful and you needed it. So if you want more of this content, please subscribe to my YouTube channel. When you subscribe, that will actually be a support to me, and if you like and you share the video, you're actually contributing to the growth of this community brought to you by KET Academy. So more videos will be coming your way. Just make sure to subscribe to my YouTube channel so that whenever I make any content, you will be the first to be notified. Also make sure to turn on the bell notification. Okay, have a nice day.